Okay, this one here, right? This one here.
Yes.
Okay, find the equation of the tangent line to the graph 3 to the sine of x. So the rule for 3 to the sine of x, this is going to follow the a to the u rule, which is natural log of a times a to the u times u prime. So the order pair is just plugging 0 into the original function. 3 to the sine of 0 minus 4. Anything sine of 0 is 0. Anything raised to 0 is 1. So 1 minus 4 is negative 3. So there's my order pair, 0 comma negative 3. My derivative, 3 to the sine of x, will be natural log of 3 times 3 to the sine of x times the exponent's derivative, which is times cosine of x. And then the minus 4 goes to 0. Next up, we replace all the x's with 0. So natural log of 3 times 3 to the 0, which is 1. Cosine of 0 is also 1. So that just gives me natural log of 3. So my slope is natural log of 3. My order pair is 0, negative 3. And then my point slope form, part B, answer choice B. Hey, good morning.
I'm sorry, Mr. Yang. Could you go over that one more time? My Wi-Fi dropped in the middle of the call.
Okay, sure. So the original function, we can use 0 to find the y value. So anything 3 raised to the sine of 0 is going to be 0. So 3 to the 0 is 1. 1 minus 4 is negative 3. There's my order pair. To get to my derivative, I have to use the rule a to the u, which is natural log of a times a to the u times u prime. My a is 3. My u is sine of x. So it's natural log of 3 times 3 to the sine of x times the exponent's derivative. So sine becomes cosine. And then minus 0. Plug 0 in for the derivative. That's going to clean up to be natural log of 3 times 3 to the 0, which is 1, times cosine of 0, which is 1. And that gives me a slope of natural log of 3. Order pair is 0, negative 3. And then here's my tangent line equation. And then answer choice B.
Thank you.
Mm-hmm. Yeah, there's only a few students, so if you have any questions you want me to go over or me to walk over any problems, I can do that. The morning review or the review that you've been working on?
It's the one that we had in class.
In class. This one, right? Okay. Okay, so first, we go ahead and we find f prime first, or our dy dx first. So we jump into our derivative step. X squared becomes 2x, y squared becomes 2y, dy dx equals 0. And then we just solve for dy dx. So we subtract 2x, divide by 2y, and we clean up to negative x over y. That's the halfway point. So now to find the second derivative, I have to go through quotient rule. So f prime g minus fg prime all over g squared. So negative x becomes -1. We'll keep the y minus a negative x, and then y's derivative is going to be dy dx, 1 dy dx, all over my denominator squared. Okay. So now I'm basically at my second derivative. I just want to replace dy dx in terms of x and y. So I replace that dy dx with negative x over y. And from here, it's not asking for me to find the second derivative. It's just asking to find the second derivative at the order pair 2, 3. So I don't want to do so much cleanup. Just replace every x and y with 2 and 3 and see if I can get myself down to a number, which will be my second derivative value. So -3 minus 2 squared over 3, all over 3 squared. So that's -3 minus 4 thirds, which is -13 thirds. -13 thirds divided by 9 is the same thing as -13 thirds times 1/9, -13 over 27.
Okay, thank you so much.
Yeah. Yeah, so if you want to take a look at the morning review, we can go over any of those problems if you want. You got the morning review, did you? Or did you? You did something, right? Yeah, so look through that. Yeah, if you guys want to work through the morning review, or I mean, go through any problems you want me to go over, I can do that.
Actually, on the test review, can you go over number 10?
The morning review or the review we've been working on in class?
The review we've been working on in class.
Okay, so we want to find the second derivative at 0, -1. So let's find our way to dy dx first, and then we can find dy d2 over dx2. So x becomes 1, y squared becomes 2y, dy dx. We're asking for y's derivative, so we need to attach dy dx. Cosine becomes a negative sign. The two negatives cancels out. And then I'm just trying to solve for dy dx. So 1 minus sine x equals 2y dy dx. Divide both sides by 2y. So this is my halfway point. This is my first derivative. Next up, I want to get to my second derivative. There's a numerator denominator portion. I'm going to go through quotient rule. So f prime g minus fg prime all over g squared. So here's my quotient rule. 1 minus sine x becomes negative cosine x. I keep the g function, the f function stays, and then 2y, which is my g prime, 2y's derivative will give me 2 times dy dx. All over denominator squared. Don't forget about that. From here, I'm not really trying to clean up my second derivative. I just want to be able to get down to my second derivative value. So what I did was I knew that my dy dx was 1 minus sine x over 2y. I just went ahead and plugged in 0, -1 to get my slope value, my dy dx value, and I just took that 1 minus sine of 0 over -2, which is -1/2. And I just want to save a little bit of time, so I just took that slope value and plugged it in for dy dx, because that would be what my dy dx value would be if I were to put all that here and then plugged in 0, -1. So -1/2 just goes in here, and then I went ahead and replaced all the x's and y's with x with 0 and y with -1. And that got me down to this point down here. So negative cosine of 0 is -1 times -2 minus 1 times 2 times -1/2, which is -1, all over 4. So 2 plus 1 is 3. 3 over 4 is 3/4.
Thank
So
you.
I kind of moved around here. I ran out of room, so I used the bottom of page of problem 11 to finish my number 10.
Mr. Yang.
Yeah.
How do you differentiate when to use chain rule versus implicit rule? Like, how would you know?
Anytime you see y's out of place, you know you got to do implicit. Yeah. So anytime there's multiple y's, or there's y squared or y cubed or square root of y, you know there's going to be implicit. Yeah.
Okay, got it. And whereas chain rule, where it's like a sign you know, would be chain rule. When it's like
Yeah.
a inside and outside function.
Yes, chain rule would be if I have a function within a function, usually like parentheses with multiple terms inside, and then parentheses with an exponent outside.
Okay, got it. Okay, thank you. Could you go to number 6 on the unit test review?
Number 6.
Number 2.
Or number 2.
No, the worksheet number 2, sorry. Number 6 on the worksheet number 2.
Yeah. Okay, this one here.
Yes, yes.
Okay, so we have everything is raised to the second power. You see a set of parentheses. So that tells us that chain rule will come first.
Mhm.
So we'll do parentheses squared, and then we can take care of the h of x over g of x. So the outside's derivative, we go through power rule. So that becomes 2 parentheses to the first power. So that takes care of my outside's derivative. And now we can move on to the inside portion. The inside portion, we can go through chain rule, quotient rule. So f prime g minus fg prime all over g squared. And once we're here, then we're pretty much done with the calculus. We're just replacing every x with 0, find f prime of 0. And then once we replace everything with 0, we just look at our table to see if we can make those substitutions out of function notation into an integer value, and then combine all those numbers down to 56 over 125.
And how did you know you had to plug in 0?
It says here at the top, find f prime of 0.
Got it. Okay.
you have any questions, we can go over any, yeah. It's only a few students, so just ask whatever you want me to go over.
13 and 16
Okay, is the morning review or the
from the
rate?
test.
Okay, worksheet 1. Bye, see you. You said 13 and 16?
Mhm.
This one here, right? This one. All right, so it says find the second derivative, and let's first focus on the first derivative. So this e to the x to the fourth, we're going to follow the rule e to the u, which is e to the u times u prime. So the derivative of e to the x to the fourth is just e to the x to the fourth times the exponent's derivative, so times 4x cubed. So that gets me to my first derivative. Okay. We get to my second derivative. I now notice there are two different variable expressions that are being multiplied, so I got to go through product rule. So f prime times g plus f g prime. And then with f prime, I got to go through another thing that I just did, e to the u times u prime, to get to this portion's derivative. Now I'm just cleaning up to get to my cleaned up version.
Possible to do log differentiation for the first derivative.
I wouldn't suggest that. I think that just makes things more complicated. I would only save log differentiation if it's really, really complicated, whereas like it's already power rule and chain and quotient all meshed into one, or if I'm a variable raised to a variable. Yeah, otherwise, I mean, technically you could get the right answer, but if it's multiple choice, it'll be really hard to match that answer choice. Good morning. 16. Okay, so 16, I went through first derivative. I know there's implicit going on here. So 2x plus 2y dy dx equals 13 goes to 0. And now I'm just trying to solve for dy dx, which is negative x over y. So that's my halfway point. Next up, if I want to find the derivative again, I notice there's a variable divided by a variable, so I got to go through quotient rule. And there's still a y involved, so there's going to be implicit that's going to show up along the way. So f prime times g minus fg prime. So y's derivative becomes dy dx all over denominator squared. Okay. From here, I replace the dy dx in terms of x and y. And then I'm just replacing all my x and y's with 2 and 3 and trying to get my way down to a number to represent my second derivative value.
So can we leave derivatives as complex functions?
Yes, you can.
Okay. And do we have to do that notation?
This is typically the standard notation. That just indicates I want to plug in the order pair into my second derivative. Yeah.
Also, 14 from the morning review.
Mm-hmm. Okay, so let's find the equation of all horizontal and vertical tangent lines. We know we have to get to the first derivative here. So we'll go through power rule for each, and then there's implicit that has to be involved here because we have y's mixed into the equation. X squared becomes 2x, 10x becomes 10. This becomes negative 35y to the 4th times dy dx. And now we just want to solve for dy dx. So divide both sides by negative 35y to the 4th. So this is my dy dx. If I want to find the horizontal or vertical tangent, I have to look at the derivative and set either the numerator or the denominator equal to 0. So if I look at the numerator, that's going to be where I'm going to find a potential horizontal tangent. And if I look at the denominator, set that equal to 0, that's going to be where I'm going to find my vertical tangent. So I set my numerator equal to 0. I get 2x plus 10 equals 0, 2x equals negative 10, x equals negative 5. Now, I have a location for my horizontal tangent, but I know that a horizontal tangent is going to have to be a y equals equation. So I don't have my full information yet. So if I want to get more information, I'm going to take that negative 5, insert back into my original equation, and see if I can gather more information so I can get to my y equation, because I only have the x value, but I need the y value. So negative 5 goes in for all the x's for my original equation, and I'm just trying to solve for y, and I get negative 35 equals negative 7y to the 5th, divide both sides by negative 7, y to the 5th equals 5, so y equals the 5th root of 5. So this is my horizontal line equation. Yeah. Now, if for some reason you're able, let's say it was like 2y plus 10 equals 2y plus 10 equals 0, then once I solve for y, then I'm done. There's nothing more I need to do. But because I was sitting at an x value, I had to go a little further since I was looking for a horizontal line. Okay, a vertical tangent, I'm going to look at the denominator, set the denominator equal to 0, negative 35y to the 4th equal to 0, divide both sides by negative 35. So I get y to the 4th is equal to 0, take the 4th root of 0, I still get 0. But y equals 0 is a location, but it's not a vertical tangent line. I need the x equals as a vertical tangent. So I'm going to go back to my original equation, plug in. But unfortunately, this ends up not factorable. So I have to go through a quadratic formula. And that's going to give me two messy decimal values. So x is equal to 10 plus root 140 over 2, and x equals 10 minus root 140 over 2. So there's actually two vertical tangents.
Well, if you.
No, probably won't give you one with quadratic formula. But it's good to know the process, though. Understanding that we do have to get to an x equals to create those vertical lines.
So would there be one like without using the quadratic formula, or would there be a question with that?
Yeah.
Okay.
How'd you get the 5th square root for the horizontal tangent? It's like a little 5.
5th root. Yeah. So if I have y to the 5th is equal to 5, if I take the 5th root,
It gives you the 5. Okay,
yeah. So y is
Gotcha.
equal to the 5th root of 5.
Got it. Okay.
Could you tell me on page 15 of the packet?
This one here.
Mhm.
Okay, find the slope of the normal line. So normal line means a slope that is perpendicular to the tangent line. So I know I have to go through implicit. And there's also a little bit of chain here. So y becomes 1 dy dx. X becomes 1. And then cosine of u becomes negative sine of u times u prime. And u prime means I have to find the derivative of that xy. And to get the derivative of that xy, I got to go through product rule. So f prime times g plus f g prime. And because y's derivative is implicit, I got to do times dy dx. Next up, I was trying to get that. Let's see. Yeah, I wanted to group my dy dx's together. So I had to take this negative sine of xy and distribute it through that bracket. So I can release this, so I can move this around. So negative sine xy times y will become negative y sine xy. Negative sine xy times x dy dx will be negative x sine xy dy dx. And now these are free to move. I can move this to the other side with that dy dx. And once I do that, I can factor dy dx out. I'm dividing this whole thing back over to the other side to isolate dy dx. And then I replace all my x's and y's with 0 and 1 and make my way down to 1. So that's the slope of my tangent. The slope of my normal will be the opposite reciprocal. So I got to flip 1, which is still 1, change the sign, so they're negative 1.
Could you go through number 11 on the which one is this? On the worksheet number 2, morning review.
This one here.
Yes.
Okay, so anytime we see so it's asking for the slope of the tangent, so it's just finding the derivative and then plugging in the power of 3. Anytime we see that shorthand form, we always want to rewrite it outside a set of brackets, so we can clearly see the chain rule involvement here. So this is chain rule. You got the outside portion, which is that bracket squared, and you have the inside portion, which is that sine of x over 2. Or in other words, sine of 1/2 x, if you want to look at it without that denominator under the x. Okay, so we take turns with each derivative. Bracket squared becomes 2 bracket to the first power. We can just go through power rule there. So 2 bracket to the first power. So we're done with the outside portion. Now moving on to the inside portion, sine of u becomes cosine of u times u prime. And then now I'm just trying to clean up. So 2 and 1/2 cancels out. Sine of 1/2 x times cosine of 1/2 x. And now I'm just replacing x with pi over 3. So that gives me 1/2 times pi over 3, which is pi over 6. And then sine of pi over 6 is root 3 over 2. I'm sorry, sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. Combine that to be root 3 over 4. Which morning? So this one, yeah, this one here. This one is also chain rule. We have to recognize the need for that outside portion first, followed by the inside portion. So the outside portion, we go through power rule. 2 parentheses squared becomes 2 parentheses to the first power. And then now we're done with the outside. We can move on to the inside. The inside, we can go through quotient rule. F prime g minus fg prime all over g squared. Now, the problem says find f prime of 0. So we can replace every x with 0, and then now we're just off to pulling values from the table to get it down to a number. Okay.
Mr. Oh, you can go first. Or sure. Could you go over number 9 on the morning? Or wait, it was like only the back of the first page on the very bottom.
Yeah, I had the order mixed up here. This one here. It says find the equation of the tangent line. So I just had to get to my slope. But first I have to get to my derivative, and I also know there's implicit involved since I have to get to dy dx, since there's y's mixed into my equation. I opted to just go through chain rule here. So parentheses squared becomes 2 parentheses to the first power, and then I'm ready for the inside portion. So x becomes 1, and y becomes dy dx. Minus, okay, 4x becomes 4. 20y becomes 20 times dy dx. And I decided that I wasn't going to solve for dy dx because the problem doesn't care about the dy dx. It just cares about the slope. So my shortcut is, rather than trying to solve for dy dx and keeping track of all my variables, why don't I just go ahead and plug in at this stage, since it's already a derivative, it's just not as clean as it could be, replace all the x and y's with 4 and 2, and things will combine a lot faster, and I can just solve for dy dx a lot quicker without having to keep track of all these x's and y's. So x gets replaced with 4, y gets replaced with 2. So things combine a little faster here. 2 times 2 is 4, times 1 minus dy dx, minus 4 equals 20 dy dx. I get 4 minus 4 dy dx minus 4. The 4's cancels out. 4 dy dx equals 20 dy dx. I'm not going to be dividing because I want to group my dy dx together. So I added the 4 over to the other side. 20 dy dx plus 4 dy dx is 24 dy dx. And that adding is going to force this one side to be 0. And then now I can solve for dy dx. Divide both sides by 24. I get 0 over 24. So my slope is 0.
Would you, instead of just plugging in the point, how would you get the x, y, c?
Isolated. All right.
Would you have to distribute it?
Yeah, it's a little bit messier here.
So when you're finding the tangent line, you can, once you find the derivative, you can just go ahead and plug in.
Asian plug in. Yeah,
You don't have to isolate.
you don't have to isolate unless it's asking for dy dx. Then you're forced to isolate. But yeah, I would distribute this through, and then I would have to boil this out.
What happened to the 4?
Oh, yeah, -4.
Okay. It doesn't matter which side you put the.
Yeah. It doesn't really matter. Yeah, divide all that over,
Okay,
right?
okay, thank you. Can you go over number 21?
Okay, morning review.
Yeah.
Okay, so 21, we have y equals arc cosine 3x. So first, why don't we just go ahead and find the order pair? It's asking for a tangent line equation, so. So in other words, this is basically saying what theta value will allow cosine to be negative root 3 over 2. And that's going to be in the second quadrant. So that's going to be in that pi over 6 family. So we know it's going to be 5 pi over 6. So our x value is negative root 3 over 6. Our y value is 5 pi over 6. So there's my order pair. Next up, I need to find the slope. To find the slope, I got to get to the derivative. Arc cosine looks a lot like arc sine, just a negative version of arc sine. So arc sine is negative u prime over square root of 1 minus u squared. Now I can replace my x's with negative root 3 over 6. This reduces to be negative root 3 over 2. Which if I continue furthering reducing, the negatives cancels out. I'm left with just 3 over 4. So negative 3 over square root of 1 minus 3 over 4. So 1 minus 3/4 is the same thing as 4 over 4 minus 3 over 4, which is 1/4. And 1/4 the same thing as, or square root of 1/4 the same thing as 1/2. And if I flip that, dividing by 1/2 is the same thing as multiplying by 2. So my slope is negative 3 times 2, which is negative 6. So I have my order pair. I have my slope. And now point slope form. See ya.
Could you run the number 8 real quick? Thank you.
Worksheet 2.
Yes, on the morning review.
Okay, so equation of tangent line. We have to get to our order pair and slope. Well, we already have our order pair, just have to get to the slope. And we see there's y's involved. So we got to go through implicit. X squared becomes 2x. Y squared becomes 2y. dy dx, 27 goes to 0. Now I'm just trying to get dy dx by itself. Divide both sides, or subtract 2x over to the other side. Divide both sides by 2y. I get x over y. This is my slope formula. So now I can plug in 6, -3, 6 in for x, -3 in for y to get to my slope. So I have my order pair, my slope, and now point slope form.
Got it. Okay, thank you. Well, for all of these, do you always get x over y? Could you just skip to that step where it's just 6 over 3, no -3? Or is it different for every time?
What do you mean? What's different every time?
Like, does it always go from when you're using implicit rule for these type of questions? Does it always go to x over y? I'm asking if you could just click.
We can't guarantee it, right? Because if you look at number 9 is also implicit, but
Right.
derivative is not x over y here.
Okay, yeah, that makes sense. Okay.
All right, I'll see you guys in class.
All right, bye.
Bye.